So now we're going to look at trig equations again, but we're going to look at more complicated stuff using solving strategies you guys have been using for years. But now that we have an idea of it, we can look at some different equations. So first thing would be something like this. Okay, so 2 sine theta plus the square root of 3 equals 0. All you guys have to think of it like is this. You use all the strategies, you subtract, you divide, how you've been solving equations for years. So we're trying to get this little theta here. Just pretend that's our x. So all we're going to do, move the square root of 3 to the other side, make sure it becomes negative, and we're going to divide by 2. Okay, we looked at these types of things yesterday. So we said we're not so much worried about the inverses anymore. Okay, but just basically anywhere where the sign is negative square root of 3 over 2. This will tell you how many solutions I want. So it'll give you a range. So sometimes it may be 0 to 4 pi, or the first 8, or only 0 to pi. Okay, so this case it just wants 0 to 2 pi. But we're going to do the same things. So if we know sine's negative, it's got to be here and here. Here's your negative square root of 3, negative square root of 3. That means this has got to be a 60, and that's got to be a 60. Okay, but we don't want those. We want where they come all the way around to it. So to get to here, we're going to say that happens at 4 pi over 3. Get in the habit of putting the 2 pi k in there, because sometimes you'll see when we do this interval 0 to 2 pi, we may actually get more than 2 solutions. So there's the first one. If we want to get all the way to this guy over here, we're going to say 5 pi over 3 plus 2 pi k. Now you could also do the negative thing. Just realize that's not going to fit into your interval here because I want to start at 0. So instead of going negative a third of pi, you should go all the way around to 5/3. Okay. Now we start plugging the k's in. 0, 1, 2, etc. We find it's going to push us outside of the 2 pi. So we get rid of these. Here's our 2 solutions. Okay. One thing that's going to be nice about these, just like with anything in algebra, is if you think something's an answer, you should be able to plug it into your table and double check. So if I go to my y equals and I punch this guy in exactly as it is, make sure you close off your parenthesis here. If you're going to be checking radians, make sure your mode's in radians. If you hit second table and you put this independent on ask, you can punch in anything you want. So now when we go, second window is where that menu is. So if we go second table now, if I come up here, I should be able to punch in 4 pi divided by 3, and it works. Same with 5 pi divided by 3. They both give me 0, so I know I'm good. Okay? Now this guy. So cosine of a double angle equals negative 1/2. If you grab your yellow sheet, you'll realize you have double angle formulas, but those aren't going to do you any good because we're just going to make this thing more complicated. It doesn't necessarily help us out. So we want to find the general formula in the first 6 solutions. So yesterday we looked at 8, now they're only asking for 6. So there's not a range for them here, just wherever the first 6 are. The way you got to consider these is just whatever's in here, just call it a blob. Okay? Because we've done the problem of cosine theta equals negative 1/2. So we want to look at this now. We can take care of the blob later. So just figure out where the cosine's negative 1/2. It's got to be at those 2 places right there. So if this is your square root of 3, that means this is 60, That means this guy down here is also 60. That means to get there, this happens at 2 pi over 3 plus every 2 pi k. Because we can keep coming around and around and around again, we need 6 solutions. This guy here happens at 4 pi over 3 plus 2 pi k. So those two pieces right there aren't any different than what we've been doing. Now what you want to do is go take care of that blob. So you've basically said cosine of a blob equals -1/2 here and here. Just set these guys, or substitute in what the blob is. So say 2 theta equals 2 pi over 3 plus 2k pi. And also 2 theta equals 4 pi thirds plus 2 pi k. All you have to do now is solve for this theta. And this method's going to work for anything in the blob. A 3, a 4, a 1/2, addition, subtraction, anything like that. Divide by 2, divide by 2, and make sure you divide this guy by 2 as well. Divide by 2, divide by 2, divide by 2, and see what happens. So now theta equals 2 pi over 6 plus pi k. Theta also equals 4 pi over 6 plus pi k. Here's the things we want to work with. Those are our general formulas. Now we need the first 6. So take those guys there and start kicking in the k. So if k is 0, it's going to happen at 2 pi over 6. So I'm just going to write that as pi over 3. Okay. Now let the k be a 1. So again, it may be helpful to go up here and change this guy again. If we're doing pi, let's do 6 pi k's over 6. You can reduce them to thirds if you want. We'll just simplify everything one step later. Okay, so the next one happens at 8 pi over 6. We're going to have to go reduce that one. Next one happens at 14 pi over 6. We want 6 answers, not 8, so we'll stop right there. We'll take these guys, simplify them down. So pi thirds, 4 pi thirds, and 7 pi thirds. There's your first 3. Now to get these last ones, let's go to the second equation down here. Rewrite this guy as well as 6 pi k over 6. So when k is a 0, the first one happens at 4 pi over 6. We'll reduce that later. Next one happens at 10 pi over 6, and the next one happens at 16 pi over 6. So 2 pi over 3, 5 pi over 3, and 8 pi over 3. So let's go back and check our answers in our calculator here. So I want a cosine of a 2x. I want it to equal -1/2, so just keep that in mind. Make sure you're again in radians. Go to your table. If you think these are the answers, we should be able to plug them in and they should give us -1/2. So hopefully that works. Pi divided by 3, there you go. 4 pi divided by 3, there's a -1/2. 2 pi over 3, again, and all the others will work as well.